Hello everyone. Th- Today we will going to see some practice questions from the chapter coordination compounds. This is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images in this deck and you have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index, and today we will going to see the practice questions from question number 9 to question number 16. Let's start with the question number 9. The number of geometrical isomers of the complex cobalt NO2 whole thrice NH3 whole thrice is. So we have given a complex here. We have to tell that how much or the number of geometrical isomers we can get for this complex will be. Options are 2, 4, 3 or 0. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is 2. So complex which is given as cobalt NO2 whole thrice NH3 whole thrice is of type MA3B3, right? Which have two geometrical isomers. If you draw, then which is basically facial, also known as FAC, and meridional, which is MER isomers. So we can have different types of complex, which we can write commonly as MA3B3, MA2B2, A4, or MA2. MAA2B2, something like that. So this complex which is given in the question, it is of form MA3B3 and it generally is having two geometrical isomers. One is facial and another one is meridional. Okay, that's why the number of geometrical isomers shown by the given complex will be 2, and thus our option A is the correct answer. Okay, let's move on to the next question. Question number 10. The complex platinum pyridine NH3BrCl will have how many geometrical isomers? Again, we have to tell the number of geometrical isomers in this complex given. Options are 2, 3, 4 or 0. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is 3. So you can also see that the complex which is given in the question, it is of type MABCD because all the ligands are different and no ligand is present double or triple time. So its general formula will be MABCD type. So this type of complex have 3 number of geometrical isomers. As you can see, in first one we have platinum, pyridine NH3BrCl. Then we just fix the position of the pyridine and interchange the positions of rest of the ligands. Then we will get this structure which is platinum, pyridine, bromine, ammonia, chlorine, and then again we fix the structure of pyridine, fix the position of pyridine and interchange the positions of rest of the ligands, and we can get this third number of geometrical isomer, which is platinum, pyridine, ammonia, chlorine, bromine. All these 3 are different from each other in a way, and hence we can get 3 number of geometrical isomers for the given MABCD type complex, and thus option B is the correct answer. Okay, let's move on to the next question. Question number 11. The number of geometrical isomers that can exist for square planar platinum Cl-Py NH3 NH2OH whole positive is? Py is pyridine. So we have to again find out the number of geometrical isomers which can be exist for the given square planar complex. Options are 2, 3, 4 or 6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is 3. Again, we have this platinum, chlorine, pyridine, ammonia, NH2OH whole positive, a square planar complex given, which is of type MABCD, right? The structures are formed by fixing a group and then arranging all the other groups around a central atom. And hence, in this way, we can get the 3 geometrical isomers for the given complex. You can see here. First one is platinum, pyridine, ammonia, and H2H chlorine. We just fix the position of pyridine and interchange all these 3 positions of our ligands. We will get platinum, pyridine, and H2H, ammonia, chlorine. Again, we fix the position of pyridine here and interchange the rest of the ligands. So it will be platinum, pyridine, NH2OH, chlorine, and NH3. Right? And in this way, we can get 3 different geometrical isomers for the given complex, and thus B option is the correct answer. Okay, let's move on to the next question. Question number 12. Consider the following reaction and statements. We have given a reaction here for the complex compound and some statements. Reaction is cobalt NH3 whole 4 Br2 whole positive plus Br negative, giving us this complex of cobalt NH3 whole thrice Br3 and 1 molecule of ammonia. Statement 1 is 2 isomers are produced if the reactant complex is a cis isomer. So it is given that if our reactant complex, which is this, right, so if the reactant complex is a cis isomer, then we will get 2 isomers in the final reaction. Or statement 2 is 2 isomers are produced if the reactant complex is an trans isomer. So if it is a trans, it will produce 2 isomers. Third statement, only 1 isomer is produced if the reactant complex ion is a trans isomer. Again, we have given that if the reactant complex is trans isomer, only 1 isomer we can get. And the fourth statement is only 1 isomer is produced if the reactant complex ion is a cis isomer. So if it is a cis isomer, it will produce only 1 isomer. So we have given these 4 statements on the basis of the given reaction. We have to find out the correct statements will be. Options are first and second, first and third, third and fourth, or second and fourth. So choose the correct statement from the options. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is first and third. Okay, so if the reactant is cis isomer, then the following reaction takes place. We have given a reaction here. So basically, we have taken the reactant as a cis isomer in a cis form. You can see bromine is adjacent to each other, ammonia is adjacent to each other, so it is cis isomer. So if we will take cis as the reactant as a cis isomer, and on reacting with bromine negative ion, it will give us 2 isomers, right? One is facial, other one is meridional. You can see it, right? So you can say that if reactant is cis isomer, it will produce 2 isomers, right? And if the reactant is trans isomer, then the following reaction takes place. So we just put the complex in the trans form. So Br is opposite to each other, you can see. So this is the transform of the reactant. When it will be reacted with the bromine negative ion, it will form the meridional isomer. Okay, that is that only one isomer is produced when the reactant is a trans isomer we used. Thus, you can say that statement 1 and 3 are correct. Okay, and the option B, which contain both statement 1 and 3 as correct statements, is the correct option. Okay. Now let's move to the next question. Question number 13. Which one of the following complexes shows optical isomerism? So we have to tell that from the given complexes in the options, which one show optical isomerism? Okay. So options are cis cobalt En whole twice Cl2 Cl, trans cobalt En2 Cl2 Cl, or cobalt NH3 whole 4 Cl2 Cl, or cobalt NH3 whole thrice Cl3. So you have to tell that among the 4 options, which of the complex show optical isomerism. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option A, that is cis cobalt En whole twice Cl2 Cl. So the compound or the complex cobalt En whole twice Cl2 Cl, it is of type MAA2B2, because En is a bidentate ligand, so it will attach to the central metal atom cobalt with the 2 bonds. Okay, so that's why we represent it by AA. So the common formula will be, general formula will be MAA whole twice B2, where only cis isomer shows optical isomerism. So we just draw the structure for this cis cobalt En whole twice Cl2 Cl. So it will be CO, Cl2 and En2. You can see, right? It is also CO, Cl2, En2. But only the difference between these two will be that this is the cis form. The first one is the cis form, which is optically active. Second one is trans form, which is optically inactive due to the plane of symmetry. Okay. So due to the plane of symmetry, the second one is optically inactive, but first one is optically active, as no plane of symmetry is present in the first isomer of the or cis isomer of the given complex. Right? Now, if you see in the case of cobalt NH3 whole 4 Cl2 Cl, it can exist in both cis and trans form. Like this will be the transform CO, Cl2, NH3 whole 4. We arrange the ammonia and chlorine opposite to each other. Chlorine opposite to the chlorine, ammonia opposite to the ammonia. This is trans cobalt NH3 whole 4 Cl2 Cl. This is optically inactive compound because plane of symmetry is present. And the cis form is also there for the cobalt NH3 whole 4 Cl2 Cl. And you can see 2 chlorine is adjacent to each the ammonia that's into the, so it is cis form. It is optically inactive due to the presence of the plane of symmetry in it also, right? And now if you see the third one, CuNH3 whole thrice Cl3, it exists in FAC and MER isomeric forms, FAC and MER isomeric forms, and both are optically inactive. So this is FAC isomer, which is optically inactive, CuNH3 whole thrice Cl3, right? This is FAC isomer, and this is optically inactive due to the presence of symmetry. And the MER isomer, meridional isomer, is also optically inactive. You can see cobalt, ammonia, whole twice, Cl, ammonia, Cl2, right? So this is a MER isomer. This is optically inactive isomer. Okay. So it also exists in FAC and MER form, and they both are optically inactive. In the second option also, the complex can exist in both cis and trans forms, and both are optically inactive due to the presence of symmetry. But in the first case, this cobalt in whole twice Cl2Cl, it is of type MAA2B2, and in the options A and B, both cis and trans are. So only cis is optically active, trans is optically inactive due to the plane of symmetry. That's why the option A is the correct answer. Okay. Now let's move on to the next question. Question number 14. So, which of the following complex species is not expected to exhibit optical isomerism? So, we have asked that from the given options, which one complex species is that which is not expected to exhibit optical isomerism? Options are cobalt En whole twice Cl2 positive, cobalt NH3 whole thrice Cl3, cobalt Cn NH3 whole twice Cl2 positive, or cobalt En whole thrice whole 3 positive. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is cobalt NH3 whole thrice Cl3. So optical isomerism is exhibited by only those complexes which lacks plane of symmetry, in which the plane of symmetry is not present anyway, are the optical isomerisms or isomers. So in a cobalt NH3 whole thrice Cl3, it is a type of Ma3B3 complex, right? Because A is ammonia, B is chlorine, and ammonia is present 3 and the 3 numbers, and chlorine is present 3 numbers. So Ma3B3. It shows facial as well as meridional isomerism, but both forms contain plane of symmetry, both facial and meridional, and thus this complex does not exhibit any kind of optical isomerism, because for the optical isomerism there should be a lack of plane of symmetry, or otherwise there will no optical isomerism will be obtained. So this is the complex we have here in the option B, which is of type Ma3B3, and it shows facial as well as meridional isomerism, and both forms contain plane of symmetry. That's why this complex is not expected to exhibit the optical isomerism, and thus B option is the correct answer. Okay, let's move on to the next question. Question number 15. Which one of following has an optical isomer? En is ethylene diamine. So we have to find it from the options which one complex is having optical isomer. Options are zinc, ethylene diamine, NH3 whole twice, whole 2 positive. Cobalt, ethylene diamine, whole thrice, whole 3 positive. Cobalt, H2O whole 4, En, whole 3 positive, or zinc, En whole twice, whole 2 positive. So you have to tell which one of the following has optical isomer. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is cobalt En whole thrice 3 positive. So this complex is of type Ma3 because only ethylene diamine as a ligand is present, which is bidentate ligand, and it has no plane of symmetry and the center of symmetry, and that's why it is optically active. It is considered as optically active. Why? Because we just see that it has no any kind of plane of symmetry, no center of symmetry. That's why it is optically active. You can see here the images, the mirror images or known superimposable mirror images of cobalt En whole thrice complex, and there is no plane of symmetry or center of symmetry observed, and that's why it is an optically active compound, and thus option B is the correct answer. Okay, let's move on to the next question. Question number 60. Type of isomerism which exists between palladium C6H5 whole twice SCN whole twice and palladium C6H5 whole twice NCS whole twice is. So we have given two complexes here, formula, and we have asked that what type of isomerism linked between them, exist between them. Options are linkage isomerism, coordination isomerism, ionization isomerism, or solvent isomerism. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option A, that is linkage isomerism. So the given compound or the given complexes in the question we have show linkage isomerism. Why? Because SCN is a ambidentate ligand. What is an ambidentate ligand? Ambidentate ligands are the ligands which can connect or which can join from the different atoms present in that particular ligand to the central metal atom. For example, if you see this complex structure, palladium C6H5 whole twice, so 2 C6H5 is directly attached to palladium and 2 SCN is directly attached. So you can see bond is between palladium central atom and sulfur. But in the second complex, C6H5 whole twice, palladium and NCS. The bond is between palladium and nitrogen. But this complex or this ligand is same. NCS and SCN is same. Okay, but this ligand can combine to the central metal atom through sulfur and through nitrogen through both the atoms. That's why it is known as ambidentate ligand, and it will show linkage isomerism. So the two given complexes in the question, the isomerism exists between them is linkage isomerism, and thus option A is the correct answer. Okay, thank you.